All right. And then the last, again, 6i times 10i would be 60i squared. And then remember, square root of 2 times the square root of 2 is the square root of 4. You do multiply those. That's what it looks like now that I've FOILed it. Any questions up to this point? Okay, now that last term, that 60i squared times the square root of 4, I can simplify. Okay? I've got my 60. Remember, I squared, we talked about yesterday, equals negative 1. And we know the square root of 4 is 2. So we multiply all three of those together, and we get negative 120. Okay? Now I can combine my like terms to finish it up. It'll be 6 minus 120. That's negative 114. And then 30i radical 2 plus 12i radical 2. All that I radical 2 has to be the same, so I can put them together, which they are. That's for 42i radical 2. So that's the answer to that problem. Like I said, that's a lot like number 36, the last one you had for homework. I saw a lot of question marks and IDKs on that one today. Questions? Understand how I got everything? That's the main thing. Now, if we went over it, you understand it. If you didn't get it, that's okay. Just keep trying. Okay. Number 3 was 7i radical 2. Number 6 was 5 plus 3i. Number 9 was 8 minus 3i radical 2. Any questions on 3, 6, or 9? 12 was 11 minus 5i. 15 was 8 minus 5i. 18 was 3 minus 12i. Again, just combine like terms there. Don't try to FOIL those. That was addition and subtraction problem. 21 is negative 40. 24 is negative 18. 27, you FOIL. 20 minus 10i. Number 30, you FOIL negative 7 minus 17i. Any questions from 12 to 30 that you'd like to look at? Okay, 33, you had a negative square root of 4 and negative square root of 9. You had to change that to 2i and 3i first. And then FOIL. You did 12 minus 5i. And then 36, again, is like this one. You had to simplify the negative square root of 48 and the negative the square root of 27, and then FOIL. And when you're done, it's negative 422 minus 84i radical 3. Does everybody need to see that one, or going over that one makes better sense now? You can do it if you want to, but you don't have to. Okay, so yesterday was these complex numbers. We multiplied them, added them, subtracted them. Right, simplified them a little bit. Today we're going to divide them. Okay, so they're going to be looking like this kind of stuff. So if we think back to radicals, are we allowed to have a radical in the denominator? We're not, right? And a lot of us would like to divide the 3 into the 6, but we can't. Why? Because the 6 is not under radical, right? If it was the square root of 6 over the square root of 3, we just make it square root of 2 and be done. We could divide them. But since they're not both under the radical or both outside, I have to rationalize this denominator. I can't simplify it at all before I start. I have to take this radical 3 and multiply the fraction by radical 3 over radical 3. That's like multiplying by 1. Anything times 1 is itself, so it's just going to look different, but we're not really changing. 6 times the square root of 3 is just that, 6 times the square root of 3. And the square root of 3 times the square root of 3, the square root of 9. Well, we all know that the square root of 9 is 3, so we got rid of that radical in the bottom. That's what we want. But now I got a 6 and a 3 that are both outside the radical sign. I can divide that 3 into the 6 and go one more step and make it 2 radical 3. So this we can't leave with the radical in the denominator. We rationalize the denominator and got 2 radical 3. We've done that already this year, haven't we? Okay. Well, this is the same type of problem. Because what did we say the square root of -1 was yesterday? Square root of -1 was what? No. What was I squared? That was -1. So what's the square root of -1? I, right? So you see this I here? That's like having a radical in the denominator. We can't have an I in the bottom, the denominator. It's got to be up top. Okay? So we have to do the same thing we just did over here, except we multiply by I. You could multiply by 3i, but you don't really need it. You just need to get to an I squared. So all I need is multiply the top and the bottom by I. That way I get 3i squared in the bottom. And what do we do when we see a 3i squared, or an I squared, I guess? We get rid of it and make that number the opposite, which becomes -3. So now my problem is 6i over -3, and I can divide -3 into the 6 now because they're not under radicals or anything, so I get -2i. That makes sense? So think of i's like we do radicals in denominators. If we see an I in a denominator, we gotta get rid of it. We gotta move it out of there. So we multiply by I over I. So we would do the same thing for this problem. Move it down a little bit. Give ourselves. Okay, I'm gonna multiply this by what fraction, Ashton? Right, you could do 2i over 2i. We can do that. We'll do it the way he said. Or you could just do I over I. Okay, either way works. Okay? So how do I multiply 2i times 3 plus 5i? Yeah, we just distribute. So we get 6i plus 10i squared over 2i times 2i is 4i squared. So what do we do when we see those I squared? We change the sign, right? So I like to put it in the right order. So the -10 I'll put in front. If you don't do that, that's okay. But that's how they like us to do. The real part in front, imaginary part in the back. Now, looking at these 3 numbers, do they have a common factor? Yes. They do have 2, right? So I have to divide that 2 out. So if you don't use the 2, you just use the I, then you won't have to do this step. Okay, so either way, it's going to work. But you'll get some problems when you do, even though you might just use I or whatever. When we do some problems, you'll see that these 3 numbers will have a common factor. You need to factor it out or divide it out, so you got to reduce the lowest terms. Those 2 examples, I guess these are the ones we're worried about here. Ones with the I's. You guys already knew how to do that. We good on those? So no I's in denominators, just like no radicals. in denominator. So we got the same deal going here. Here's radicals. Do you guys remember how you got rid of the radical here in the bottom? I don't think we've done that yet this year, but we did it last year. Nobody remembers? Well, what we have to do is figure out what the conjugate we take the conjugate of the denominator and we do the same thing we've been doing. Multiply the top and the bottom by the conjugate of the bottom. Anybody remember what that is from last year? Guesses?
The opposite.
What's the opposite?
Like the sign and stuff.
Just the sign, yeah. The stage 2 in radical 5, but we're going to make it plus. Thank you, Michael. Those are called conjugates. Okay? And when I FOIL these, you'll see that the radical will get all eliminated. That's what we want. We want to eliminate the radical in the denominator. It's okay to have the radicals in the numerator, just not the denominator. So we just FOIL top and bottom. So first, the 6 times 2, we'll get our 12. Outside the 6 times the square root of 5, so we just write 6 times the square root of 5. Inside is the square root of 3 times 2, so we usually put the 2 in front of the square root of 3 when we write it. And then square root of 3 times square root of 5 is the square root of 15. So that's my numerator, just FOILing it out. Now when I FOIL the bottom, watch what happens. 2 times 2 for first. 2 times radical 5 for outside. Negative radical 5 times 2 for inside is negative 2 radical 5. And then negative radical 5 times positive radical 5 is a negative radical 25. Okay, well what happens in the middle 2 on the bottom? They cancel, right? That's always going to happen with conjugates. And we know that square root of 25 is what? 5. So that radical's gone, right? So no more radicals in the denominator. So then I just do 4 minus 5, which is what? Negative 1 in the bottom. And the top, there was no common terms or like terms, so I just have to write it out. But usually, when we do these, there'll be some like terms so we can make it a little bit smaller looking. Okay, so that was with radicals. But what am I going to do to you now? Instead of the radical, we're going to put what with the 5? And the 3. We're going to use that I. Okay? So we're doing the same thing. We're going to use the conjugate. So what's the conjugate of the denominator? Right, 2 plus 5i. So same procedure. There's got to be the opposite sign in between. If that was a negative 2, that would stay negative 2. What changes is just a minus to a plus, or if it was plus, that would be minus. And these two have to be the same then, one over the other. That's anything divided by itself is 1, so it's like we're multiplying by 1, which is okay. And then we're going to FOIL again. All right, so go ahead and FOIL top and bottom. Let's see what you get. Everybody get what I got? Any questions? Did I make a mistake? I don't think I did. Okay, so I see I squared, so what am I gonna do with those?
So like,
Change the signs, right? Remember, that's 15 times negative 1, so it just becomes negative 15. This is negative 25 times negative 1, so it becomes positive 25. What happens to the 10 i's? It can't. So my denominator is 4 plus 25, so that's 29. My numerator is 12 minus 15, which is negative 3, and 30 plus 6, 36i. If these three numbers had a common factor, I would divide by that common factor, but they don't have a common factor, so we're done. Make sense? Any questions? Look good, feel good? You are good? Come on. Wake up. You guys are awesome. Okay. One more type of problem. Got an I with a big exponent. Okay? So let's think about this. What is anything to the 0 power? 1. So that means I to the 0 power is 1. What's anything to the first power? Itself, right? So what's I to the first power? I. We talked about this yesterday. What's I squared? Negative 1. I'm making my ones look like this so we don't think they're i's. And then I to the third is like I to the first times I to the second, isn't it? Isn't that what I to the third is? So what's I to the first times I to the second? Negative I. You guys follow so far? All right, let's try I to the fourth then. Let's do this. See if I can move that up a little bit. Will that be like I to the third times I to the first, or I to the second times I to the second, right? Either way, that's I to the fourth. Let's look at this one. What's I to the second times I to the second? 1, right? I to the fifth could be I to the first times I to the fourth. What's 1 times I? 1 I. What are you noticing? It's starting to repeat that, right? So what should this one be? Negative 1. Well, you're right. And I to the seventh, what's that going to be? Negative I. That's what's going to happen. It's going to keep repeating those 4 answers. So we just keep writing all those out till we get to 153, right? That's how we want to do these, isn't it? Kennedy wants to do it that way. She loves math. No, she doesn't love it that much. I don't love it that much. Okay? So here's what we do to shortcut this. Okay? So I'm going to get rid of these because I'm going to use this area again here. All right. Take the 153 and divide it by 4. Why am I dividing it by 4? There's only 4 possible answers. That's why we're using the 4. All right. If I do long division, 4 goes into 15 3 times. Then I go 3 times 4 is 12. Then you subtract, which is 3. Then you drop down the next number, which is 33. And then you say 4 goes into 33 8 times. You put the 8 up there. You go 8 times 4 is 32. And you subtract, and you get 1. That's all I worry about on this problem. I don't really worry about, I want to do this correctly, but this is what I'm looking for. Okay? So if I would have kept going all the way up to 153, that's my exponent for I. Whatever the remainder is the exponent for I. So what's this answer? I. All right? So I to the 153 is the same as I to the first, which is I. Whatever that remainder is what, and the remainders can only be 0, 1, 2, or 3. All right? That's 4 things, 0, 1, 2, or 3. It could be a whole number when I divide the number by 4. So that would be I to the 0 then, no remainder. The answer is 1. For 153, when I divide it by 4, the remainder is 1, so that means it's I to the first, which is I. If the remainder was 2, that means it's I squared, which is -1. If the remainder is 3, it means it's I cubed or -I. Now, do you guys like doing long division? No. You like using your calculators, right? Okay, so let's look at the calculator. When I divide by 153 by 4, I get 38.25. Well, what is 1/4? That's the 0.25. Okay? So, if it's a whole number, what's the remainder? 0, right? If it's a 0.25, the remainder is 1. If the remainder is 2, what's 2/4 as a decimal? 0.5. So you'll see a 0.5 in your answer. If the remainder is 3, that's 3/4. What decimal is 3/4? 0.75, right? You guys know those, don't you? So when you use your calculator, you're either going to get a whole number, a number with a 0.25, like the one we just did, a 0.5, or a 0.75. That's the only things that will show up. So you just need to learn this little table. Okay? And you'll know the answer then, right? When you take the exponent of the I and divide by 4, you'll get some decimal answer. So you guys tell me what this answer is. 3I to the 91st power. Use your calculator. We're going to forget about the 3.
That's the part of the problem. That would be right. Okay.
Nobody in low grants access.
Yeah, I need for 3.
You still in that music during my class? Which one was it? This one, right? An I, remember? Now, the 3 is still part of the answer, so times 3. This is what? What's that? Yes. Make 3 times. Right? Okay, you should have gotten negative 3i. Okay, so if you go to your calculator, go to my calculator, there it is, and take 91. Remember, we always divide by 4, because there's 4 possible answers. That's why we're using the 4. And I get what decimal? 0.75, which means it's the same as, this is the same as 3i to the third, which is the same as 3 times negative I, right? I to the third is negative I, so my answer is negative 3i. You follow? Questions? So just take the exponent with the I, divide by 4, and then look for one of those 4 things, and then that'll tell you which one it is. Okay? Makes it a lot quicker, easier than trying to go through all of them, right? All right, that's all I got for today. Remember about conjugates? Remember? 2 plus 5i, if it was 2 minus, if it was a negative 2 minus 5i, then it's a negative 2 plus 5i. Okay?